So here is a question for people who like integration. Consider the function of f of x equals square root of x cubed plus x, and g of x equals 6 minus 3x squared, the square root of x cubed plus x. For x is greater than or equal to 0, find the area R. So we want to find the shaded region here, R. Now we know when we're doing or finding area, we have to integrate. And this is going to be a definite integral. So we're going to integrate between 0 and 1. So x is between 0 and 1, since the area starts at 0 and finishes here at 1. And then it's going to be g of x minus f of x. And the reason that is, always when we finding the area using integration, always it's the above graph minus the lower graph. So under the shaded region, the g is above the green. So that's why it has to be g of x minus f of x, which in turn will be the definite integral between 0 and 1 of 6 minus 3x squared square root of x cubed plus x, and then minus f of x, which is the square root of x cubed plus x. Now, if you look at this, this looks very complicated, because how are we going to integrate this? We cannot use substitution. So let's look for a second and try to find out what can you do to make this question doable. Okay, so just pause the video if you like integration, and try to find out what you're going to do to make this doable. Okay, so now I'm going to show you what you're supposed to do. So this is the integration between 0 and 1. 6 minus, if you notice, these two are the same right here. So I'm going to take the square root of x cubed plus x out as the greatest common factor, and then I'm going to end up with 3x squared plus 1. This minus changes to plus because we factored out a negative. Now that's exactly what we need, because now we could use substitution to solve this. Because let u be x cubed plus x, then du would equal 3x squared plus 1 dx. And therefore, to integrate this between 0 and 1 of 6 minus, now since we made this u, then this is going to be u square root of u, and square root of u is the same as the u to the 1/2. And all of this here is du, so du. And I'm just going to maybe throw an integration sign here between 0 and 1 so we can do things separately. Now here, this is going to be 6x minus, and you know when you're integrating u to the power of 1/2, you add 1 to the exponent. So that's going to be u to the power of 1/2 plus 1, and divided by the new exponent, which is 1/2 plus 1, between 0 and 1, which gives me 6x minus u to the 3/2. Half plus 1 is 3/2, and that's 3/2 as well, between 0 and 1. We're going to have 6x minus, and dividing by 3/2 is the same as having 2/3 in front of u to that 3/2, and u is this, so we're just going to change that to x cubed plus x to the power of 3/2, and it's between 0 and 1. And now we could sub in the 0 and 1 in the x's. So this is going to be 6 times 1 minus 2/3 1 cubed plus 1 to the power of 3/2 minus 70 now, 6 times 0 minus 2/3, 0 cubed plus 0 to the 3/2. Now, you know, all of this is going to be 0, so that's just going to disappear. And this is going to be 6 minus 2/3. So 1 cubed is 1 plus 1 is 2 to the power of 3/2, which equals, this is basically the square root of 2 to the power of 3. So we're going to get the square root of 2 to the 3, which equals 6 minus 2/3 square root of 8. And that is 8 is the same as 4 times 2. And then we could square root 4, which is 2 times 2 is 4. So it's going to be 6 minus 4/3 square root of 2. And that's your answer for this integral. And that's the area of R. Thank you for watching. See you next time.